In today's section, what we're going to cover is we're going to cover the monopolistic competition model. And this is for the week starting November 16th, but I'm posting it a day late, so sorry about that. But I think it's okay because just today, Professor Fowley covered the sort of standard framework of imperfect competition. And then next time we'll start on the monopolistic competition model. So I think this will dovetail nicely with that material. So before watching this section video, I encourage you to watch the video that Dennis posted recently. That's going to be section 10B, where he covers monopoly. Also, the lecture, the class lecture from today also covered monopoly. So I think before watching this video, that will be helpful. But just to give you a little bit of an introduction to the monopolistic competition model before diving into the model and sort of the setup of the model and how to sort of work through all of those assumptions there. Just a little bit of an introduction to the monopolistic competition model. So one of the reasons the monopolistic competition model might be useful is that we find that trade is often going to occur between countries with similar technologies and similar factor endowments. And so in class, Professor Fowley made the example of French cheese and Swiss cheese. France and Switzerland are both fairly similar countries in terms of their sort of skill mix, in terms of the amount of technologies, in terms of factor endowments. They're both, you think they might be relatively high in high skilled labor, but you still see trade between them. And that might be because there's sort of products that are differentiated between the two, where he's making that example of different kinds of cheese. But if you just look at the Heckscher-Ohlin and specific factors model, as well as the Ricardian model of trade, this phenomenon of trade happening between similar countries, we don't see that. And so you can go back and notice that if, for instance, we have that the marginal productivities of labor or technologies across countries or the marginal products of each factor are going to be the same across countries, and countries have the same endowment of, say, labor and capital, then in those models, we're going to find that no trade is going to occur because there's going to be no difference in relative prices between those countries when that happens, and therefore no trade, or no gains to trade, even if they were to trade. And so we're going to introduce this new model, which is going to be the monopolistic competition model. And there are going to be two key assumptions of the model, and it's going to feature internal economies of scale. That is to say, there's going to be increasing returns of scale in production. So, and what does that mean? That's going to mean that a firm's average cost of production is going to fall as it produces more. And then the next assumption is that we're going to have that there's going to be that each firm is going to have some degree of market power. So we're going to have imperfect competition. And this is similar to the framework that we saw today in lecture or in Dennis's section 10B in monopoly. So it's going to be similar to the case of monopoly, but we're going to call it monopolistic competition because it's going to have some elements of perfect competition and some elements of just pure monopoly. And so today we're going to focus on the case of one country under autarky. So let's go ahead and get started. So the key ingredients of the monopolistic competition model are as follows. So each firm is going to produce a differentiated product. You can think about maybe an almond versus a cashew. They're both in the category of tree nuts, I think. I'm not sure. I think they're both tree nuts. And then that's going to protect a firm's, but they're somewhat differentiated, and so that's going to protect that firm's monopoly power within its industry. And so because products are differentiated, an almond isn't perfectly substitutable for a cashew. I personally prefer almonds a lot. and cashews are kind of gross. Then the other assumption is that firms are going to take rivals prices are given. This is mostly to help with the math. We're going to, basically what we're going to do is we're going to walk through what one firm's optimal choice of pricing and then quantities are going to be. And that's going to be assuming that all of the firms are going to do, aren't going to change their prices in response to that price. And so that's going to really help with a lot of the math. And then basically we'll justify that by saying if each firm is acting optimally and they have the same rule, then all the firms would have the same price. But I'll talk a little bit more about that when we get to that. The next is free entry and exit of firms. This just means that if there's profits to be had in an industry, then firms can freely enter. There's no barriers to doing so. But also if firms are going to make a negative profit, then we're not going to force them to stay in the industry. Once they start making a negative profit, they're free to exit the market and close. As I already said, there's going to be internal economies of scale here, and what that's going to mean is it's going to mean that the average cost to produce one quantity of one unit of output is going to decrease as that quantity increases of production. And the final one is just going to be a statement about the utility of consumers and their preferences. And that's going to be that consumers are going to enjoy more variety as opposed to less variety. And so if consumers can choose between almonds and cashews versus almonds, cashews, and peanuts, they'll prefer almond, cashews, and peanuts because they're now consuming a wider variety of goods than they did before. Okay, so now let's jump into the setup. So potentially we're going to have many firms, and those are going to be indexed by I. And so, we can think of firm 1, where I is going to be equal to 1, firm I equals to 2, and so on and so forth. Each firm is going to produce a differentiated good. And so you can think that maybe we're in one industry, and so you can think of each firm as being within that industry. So for instance, if we're thinking about the car industry, then each firm I is going to produce some brand of cars. So you've got Toyota, you've got Subaru, you've got Ford, GM, and so on and so forth. And so it's what we want to think of is we're within one industry, and each firm is going to produce a slightly differentiated product within that industry. The cost function for all firms is going to be given by this function C of I as a function of Q. And so what this tells me is the cost of producing Q units, the cost CI of producing Q units of output, where we're just going to have that the cost is going to be linearly increasing in the quantity. So all that's to say is that however, whatever the quantity Q my firm is going to produce, it's just each unit is going to have some marginal cost of production. That's going to be CI. And then they also have to pay some fixed cost I. And so that marginal cost and their fixed cost could potentially vary by firm. And so therefore I'm writing this marginal cost CI as indexed by I, where each firm might have a different marginal cost. And so some firms might have a higher marginal cost of production, some firms might have a lower cost. Likewise, FI is going to be this fixed cost. And so why is it called the fixed cost? It's because if the quantity was 0, then if the quantity was, even if the quantity was 0, but you chose to enter this market, you'd still have to pay this fixed cost FI to enter, regardless of what you produced. And so this fixed cost FI, again, we're allowing to vary by firms. Here we're going to denote S as the total demand or market size. And so what S could represent is, suppose that, again, we're in the car industry. And so maybe demand for total demand for cars in the US is, say, $10 billion. And so S would, in this example, would then be $10 billion. N here is just going to represent the number of firms that are going to be operating. And so that's fairly straightforward. Okay, so one of the big assumptions, and this is just sort of it's going to be an assumption. So there's no steps to see that demand, what demand for good I is going to be given by. It's one of the assumptions of the model that basically the demand for a firm's output, that's going to be QI, which is going to be a function of the price, PI, that the firm is going to charge, is going to be given by this function where it's S times, and all in parentheses, 1 over the number of firms minus B, and I'll talk about what B is in a second, times PI, so that's the price that the firm charges, minus PI bar. And so there are a couple new terms here. The first one is B. And so B, I'm going to call the sensitivity of demand with respect to price. And so, for instance, if you could think that demand is not sensitive at all to price, then B would be 0. And then demand for each good here wouldn't be a function of a price. So demand for the firm, for firm output is just S over N. And so that means that if all consumers don't care about the price, then each firm, the quantity of output it's going to produce is just going to be given by the total market divided by the number of firms. So if consumers are totally insensitive to price, they're totally, their demand is totally inelastic with respect to price, then they won't care what price the firm charges. And that's the limiting case when this is 0. B might be higher, and so we'll see what that we'll mess around with the values of B later on. But that's just saying that as B gets larger, then our consumer will demand less as the price that the firm charges PI goes up. Okay. The next term is going to be P bar. And so what's P bar? P bar is going to be defined as, so suppose that we have firms that range from 1 to 2 to 3 and then to N. Well, then if we take the average over all of these firms' prices that they're charging, that's going to be given by P1 plus P2 through Pn, and then divide that all by N, or in other words, we take the average of the price across all goods. Then P bar is just the average price. And so what Pi minus P bar is measuring is it's just measuring how expensive the good that firm I is charging is compared to the average price. So notice if Pi is higher than the average price, then this is going to reduce my consumer's demand for the good that firm I is producing. If it's below the average price, then likewise, this sign is going to flip, and now consumers are going to have more demand for the good that firm I is going to be producing. Sorry about that. Okay, so hopefully all of that sort of makes sense. The way that you can see the last bit is notice that if Pi is less than P bar, well then I can just rewrite this expression as follows. I can just write this as S over N, and I can move this negative Bn inside, or at least I can move the negative sign inside. And so what does that become? This all becomes P bar minus Pi. And so this term inside would be positive. And so you can see if Pi is less than P bar, then this is going to increase demand for firm I's good. So I just wanted to write out how you can see that. Okay, and then the following demand equals supply equality holds in equilibrium. So recall that this S is the total market size, and so this is the total demand for the good. And then total demand, so this S is total demand. And then if we add up the quantity that each firm is going to produce in this market, then we have total supply. Okay, so those are the first assumptions that we're going to have in this model. Okay, so let's move to the next slide. So what now I'm going to do is I'm going to derive two key equations of this model. And I'm going to start with a PP curve. And so I'm just going to introduce what the PP curve is. And then I'm just, for right now, I'm just going to call it the PP curve. And then once I derive it, I'll explain why it's called the PP curve. So let's just go back to what we assumed was demand for each firm's output I. And so right here, I'm just rewriting. All I'm doing here is this just comes from the previous slide. So I'm just rewriting the demand for the firm's good as a function of the price it's going to charge. And then all I'm going to do here is I'm just going to multiply everything out. And so just to match the slides, if I multiply S over N out, oh, and I think I had a typo there. I needed to. In the previous slide, I wrote that S over N, this was equal to S over N plus B minus P bar minus PI. And it's, I forgot to factor out this S. And so this actually is S over N plus S times B times P bar over minus PI. So my apologies about that typo. Anyway, moving on. Sorry about that. So then if we just multiply this SB out, then we get minus BSPI plus BS P bar. Okay. And so now the next step that we're going to do is if this is our demand curve, then we want to write this as the inverse demand function. And so what is this here? This is this is the demand function, and it's basically the quantity. Excuse me, I wrote one too many I's. Quantity a firm produces as a function of its price. Function of its price. Well, then the inverse demand function then would be PI of QI. And so this is going to be the inverse demand function. And this is just the reverse. So this is going to be the price a firm charges. Oops. Price a firm charges as a function of its quantity, of the quantity it produces. And so it's going to be more helpful to take our demand function and then write it as an inverse demand function. So let's go ahead and do that. So the first step is just to take QI and then try to solve for PI as a function of QI instead. And so we're just going to take this expression up here, instead make this QI, just get rid of the function of being in a function of PI. And now all I'm going to try to do is I'm just going to try to move things over so that I can get PI just by itself. The quick way to see this is that I'm going to add BSPI on both sides. And so that gives me BSPI. And then what am I going to want to do on both sides? I'm going to want to subtract QI. So this cancels out. These cancel out here. And so do these cancel out. So I'm left with this expression in this next line. Okay. And now the only next step that I have to do is I just have to divide on both sides by BS. And so I divide by BS here, divide by BS here, and divide by BS here. So I have some cancellation. These S's cancel out, no cancellation here. These S's cancel out. And what am I left with? I'm left with 1 over Bn. So that's this term right here. So that goes there. I'm left with P. So all of the BS's cancel. So this P goes here. And then this negative QI over BS comes down right there. So hopefully you can see where I got my final expression, which now is just PI as a function of QI. And so PI as a function of QI is just equal to P bar, that's the average price, plus 1 over Bn, that's going to be the number of firms times the sensitivity of demand to each firm's price, minus Bs times Qi. And so that's saying that my price is going to, if we just look at the term in front of the Qi here, we can see that my price is going to decrease as I increase more. Okay, but I'll come back to that. Okay, so the next thing to go through is that under monopolistic competition, each firm is going to produce a differentiated good. And so it's going to act as, in essence, a monopolist for that particular good. And so if I produce almonds and other firms produce cashews and peanuts, then I'm going to act as a monopolist for my variety of almonds, because my brand differentiation allows me to exert some market power of my own. So we saw in class today that in monopoly, at the optimum, the firm is going to set marginal revenue equal to marginal cost. And so this is going to be the rule that I'm sure is familiar to you from intermediate micro, and maybe even introductory micro that you've taken earlier. And so the profit maximizing rule for someone who has market power is going to be to set marginal revenue equal to marginal cost. Notice that in perfect competition, this rule is also the same. It's just that price in perfect competition is equal to marginal revenue. But with market power, that's not necessarily the case. And so what we're going to do is we're going to figure out, just to go back, now that we figure out the inverse demand curve, just to sum up, now what we want to do is we want to figure out my brand's optimal quantity that they're going to produce. And so what we're going to do is we're going to use the rule that marginal revenue equals marginal cost. And then using that, we're going to back out the optimal quantity and then the price that they're going to produce. And so let's jump in, but I just wanted to give a sort of recap of why we're doing what we're doing. So in order to use this rule of marginal revenue equal to marginal cost, such that we can figure out what my monopolistic competitor is going to optimally charge prices and quantities, I just need to figure out what the marginal revenue and marginal cost of my monopolistic competitor are. So the first thing to do is to figure out what marginal revenue is. So it's written down here, but the first thing that's worth going through is what revenue is going to be. And so what's revenue? Revenue is just defined as P, and I'm going to write P as a function of Q times Q. If we recall that profits, so profits as a function of Q for any firm are just going to be given by its revenue minus its cost, then revenue is just given by the price of the output that my firm produces times whatever quantity of output it produces. So to figure out what marginal revenue is, to go from revenue to marginal revenue, all I'm going to do is I'm going to take the derivative of revenue with respect to quantity. Okay? And so I'm going to take the derivative of this with respect to quantity. And so what I'm going to do here is I'm just going to use the product rule. And so if you recall the product rule from your calculus class, what's the product rule here? Well, the derivative of two products, you just take the derivative of the first term times the second term plus the first term times the derivative of the second term. And so what does that give us here? Well, let's start by taking the derivative of the first term. Well, that's going to be give us PQ. So we're just going to take the derivative of P with respect to Q. If you want to rewrite that, another way to rewrite that is to write dP of Q with respect to dq, and then times q plus, and now we're going to leave the first term intact. We're going to take this, and then we're going to just differentiate the second term. The derivative of q with respect to q is just 1. So then we just bring this down, and then this is just 1. So, so my marginal revenue here, which is defined to be this, is then going to be given by p prime of q. Oh, wait. Sorry. There's a prime here. Sorry, that's a typo. So we just bring pq down here, and then we take the derivative of the second term here, which is just 1. So I'm sorry that I wrote p prime q there. So the marginal revenue here is just pq plus the derivative of p with respect to q, or p prime q times q. And so we can note that this is what the slides say. And so the slides are saying that marginal revenue is equal to p of q plus p prime q times q. Okay, so now let's plug in for what our actual example is and figure out what marginal revenue is. So I'm just going to go back here and do it just from this. So let's recall that I said that marginal revenue, and let me make this marginal revenue as a function of q, is just going to be equal to pq plus p prime q times q. Okay, so all I need to do is, I already know what p of q is, so all I need to do is I need to figure out what p prime q is. And so all I need to do is I need to take the derivative of this with respect to q. So there's no q here, so this just drops out. Again, no q in the second term, so this just drops out. So the only q is in the third term. And so if I take the derivative of negative qi over vs, the qi just becomes a 1. And so p prime of q is just given by negative 1 over vs. Okay, so then using these facts, I can figure out what marginal revenue is going to be. My marginal revenue is just going to be, it's going to be p prime of q, which is just this term, so I can plug that in a second, plus p prime of q times q. So this is p prime of q. So this times q is going to give us negative q all over bs. And then if I want to make this next step, just plugging in for what p of q is, it's just going to be given by, and sorry, I'm gonna, so this is going to be equal to p bar plus 1 over bn minus qi s over b minus, again, qi. Let me write this qi here. So I just maintain the fact that quantity charged by each firm is separate. So qi over s over b. And so then what is this equal to? Well, I can notice that I can just combine these qi over sb terms. So what do I get? I get p bar plus 1 over bn minus 2 qi s over b. Okay. And so that's what my marginal revenue is here. And so the slides hopefully say the same thing. Okay, so that's going to be the first part that we need to know when we want to use this rule that marginal revenue is going to be equal to marginal cost. So as you can hopefully see, the next term that we need to figure out is we need to figure out what our marginal cost is going to be. So as I said, each firm has a cost function given by CQI, which is, Ci of Q, which is going to be equal to small ci, that's going to be the marginal cost, times the quantity Q plus the fixed cost I. And so the easy way to see this is that the marginal cost is just going to be the little ci, or the term in front of Qi. The other way to see this is just that to note that the marginal cost of each firm is just going to be given by taking the derivative of Ci of Qi with respect to Qi. And so if I take the derivative of this, well, Fi doesn't have Q, so that just drops out. And then I'm just taking the derivative of Ci times Q with respect to Q, which is just Ci. So that's just a quick proof that the marginal cost is Ci. Okay, so now clearly we know marginal revenue, we know marginal cost, so let's set them equal to each other. So here we're just bringing in marginal cost, or sorry, marginal revenue, excuse me. And here is the marginal cost that we had that we just shown. So now let's set them equal to each other, and let's solve for the optimal quantity that my firm is going to produce when using this rule that marginal revenue has to be equal to marginal cost. So what I'm going to do is I'm going to set these equal to each other, and I'm just going to solve for Qi. So what do I want to do? I just want to get Qi by itself. And so to get Qi by itself, what I can do is I can add 2Qi over Bs to both sides. So this is going to cancel out. This gives me 2Qi over Bs. And then I can subtract Ci from both sides. Subtract this here. So the Ci's cancel. And so therefore we get 2 Qi over Bs is equal to P bar plus 1 over Bn minus C. And then the next step is going to be just to get rid of this 2Bs from this side. So I can just do it by multiplying both sides by Bs over 2, and by multiplying likewise the right-hand side by Bs over 2. And so therefore we get this final result that the optimal Qi that my firm I is going to be producing, the optimal quantity that my firm is going to be producing, is just given by Bs over 2 times P bar plus 1 over Bn minus Ci. So now we know, just using this MR equals MC rule, what my my monopolistic competitor, what my firm, what my almond producer is going to be producing when it's following this rule. So now that we know the optimal quantity, recall that I already figured out what the inverse demand function is. And so if I know what the optimal quantity they're going to produce, then I can just go and automatically figure out what the optimal price they're going to produce. So you can see that if I just take this Qi star here and just plug it into my inverse demand function, Pi of Qi, then I can already figure out what my optimal price that my monopolistic competitor is going to produce. And so that's going to be, that's written down here, but let's just, let me show you, let me prove to you that that's going to be right. So recall that P of Qi is going to be equal to P bar plus 1 over NB minus 1 over Bs Qi. Okay, and so let's come back here and now figure out what the optimal price is going to be. So you can notice that that if I plug in for Qi here, a couple things are going to happen. So notice that this Qi term here is being subtracted, or being multiplied by 1 over Bs. And so you can see that these Bs's are going to cancel out. And so carrying over this term and this term here, what I'll get is I'll get minus half P bar plus 1 over NB minus Ci. And so I can notice that this P bar minus NB, well, this term is also here. And so what I'm going to have is I'm going to have 1 P bar plus 1 over NB minus half that same thing. So what I'll be left with is I'll be left with half P bar plus half NB, and then this negative sign here cancels with this negative sign here, and so in total I'll just be left with half P bar plus NB plus Ci. And so that will tell me what the optimal price that my firm is going to set is. So just to show you how to do the math there. And the slides are showing the same thing here. So this is the same price setting law. Okay, so let's move on to the next slide. And so I didn't sort of like going back to the first slide, we wanted to derive the first equation of this model, and that's going to be the PP curve. And so just to come back to what the PP curve is, the PP curve is going to tell us what the price that each firm is going to charge. So for now, we can just think of the PP curve as just being given by this equation. I'll come back to it and I'll make a little bit more. I'll make a few more simplifications. But for now, you can just think of the PP curve as being the price that each firm is going to charge. And we'll come back to it and I'll make a little bit more, both simplifications and additions. So next, what I'm going to do is I'm going to derive the CC curve. And the CC curve is going to be another expression. I'm not sure why historically, I think historically these are called PP and CC curve. I think the easier name for the CC curve is just the average cost curve. And so the average cost curve is just going to tell us for any firm I what the average cost of producing Q units is going to be given by. So you can note that, for instance, we made the assumption that the cost for firm I of producing QI units was just going to be CI, or little ci, excuse me, times QI plus FI. And so if I wanted to figure out the average cost for producing all of those Q units, then what would I do to figure that out? Well, I just divide the cost for producing all of those units by the number of units I'm producing. And so the average cost is just going to be CI divided by QI. And so doing that math out here, well, you can notice that it's, if I just plug in this from above, I get CI times QI plus FI. And then I'm just going to divide this. Hold on, I'll just divide each side by QI. So what that'll give me is that these QIs will cancel out. And then what we'll be left with is we'll be left with CI plus FI over QI. And so that's what the slide is telling us there. So this is the CC curve, which is also referred to as the AC curve, or just the average cost curve. So the average cost. So I'll come back to this equation as well. We're going to make a few more simplifying assumptions. But for right now, I've taken the setup. I've told you what my monopolistic competitor's demand function is going to be. I've told you how they're going to produce optimally. I've told you how they're going to price things. And I've told you what their average cost is going to be. And this is going to hold true for any monopolistic competitor who has some potentially differing marginal cost, CI, some potentially differing fixed cost, FI, and so on and so forth. So we'll come back to this and we'll make a few more simplifying assumptions. But for right now, this is telling you all you need to know about my one almond firm, how they're going to price and how what their cost structure is going to look like. So now what we're going to do is we're going to simplify things, simplify the PP curve and the CC curve a little bit by making the assumption that all firms are homogeneous. So what does that mean in the context of this monopolistic competition model? Well, this means that they're going to share cost functions. And so recall that when I wrote the cost function for my firm as being given by CI of Q is equal to CI times Q plus FI. Well, all that making firms homogeneous is going to mean is that if firms had varying marginal costs and varying fixed costs, we just get rid of these I subscripts. And now it's all firms are going to have the exact same cost function. Little c, I don't know if this is clear, if that's little c, that's supposed to be little c. times Q plus F. And so all firms are going to have the exact same cost function. Excuse me. And so that's what it's going to mean. I don't know if that made it look any smaller, but that's what it's going to mean for all firms to be homogeneous. If all firms are homogeneous, then it would be weird if they didn't charge the same prices. And so that's going to mean that each firm, firm I, is going to charge a price that's going to be exactly equal to the average price P bar. And so no firm is going to deviate from the industry average. They're all going to charge exactly the same price. And then, you can go from saying, if they charge the same prices, then if we go back to our demand function, our sort of original demand function, not our inverse demand function, and we just plug in this, the fact that they're charging the same price, then obviously they're going to produce the exact same quantities if they're all charging the exact same price, because we have a function that tells us what they're going to produce, and now that function is going to be the same. And so each firm is then going to produce the same quantities, and that's going to be true for all firms. Okay, so now what we can do is we can go back to this equilibrium condition and recall that our initial one of our initial equilibrium conditions was that total demand, this is sort of total market demand, is equal to total supply. And so what this expression looked like earlier was we had that Q1 plus blah, 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 Qn had to add up to total demands. But here, Q1 is just equal to Q, and Qn is just equal to Q. And so these add up to adding up Q n times. And so this just means that each firm has to produce a quantity such that if you just multiply each quantity, the same quantity that the firm produces, by the total number of firms, you have exactly the total demand. And so using this equilibrium condition, we can back out that each firm is just going to produce whatever the total demand is divided by the number of firms. And so it's just going to produce its fair share, given that they're all producing the same quantity, its fair share of exactly whatever the market size is. And so the market size divided by the number of firms. Okay, and so now we can use this equilibrium condition that we didn't have before when we assumed that all firms are the same. And we can use this to simplify a lot of the expressions for the firms, for the price the firm was charging, and also for the cost of each firm. And so let's go through and do that. So let's start by coming back to the PP curve. So if you'll recall, I said that our monopolistic competitor would charge a price given by this. But now, with all firms, with homogeneous firms, PI is equal to P bar, and CI is equal to C for all firms. So all I can do is I can just replace this P bar with PI, and this CI with C. And so what does this give me now? This gives me now that I actually have PI on both sides of this expression. So what I can do is I can just subtract half of PI on both sides. Okay, and what I'll be left with is PI minus half of PI just gives me half of PI. So that's this first step. And then I have half of PI and half of C plus 1 over Bn. And so I can just multiply by 2 on both sides to cancel out those 1/2. And what do I get? I get that the price that each firm charges is just going to be given by C plus N over B. And of course, this is the price that any one firm charges. But of course, that's also just equal to the average price because all firms are charging that same price. And so this gives me now the PP curve. And so I'll take a moment to stop here and say, this is the PP curve when we assume that all firms are homogeneous. And so this is what we'll frequently call the PP curve, because usually almost always we'll assume the firms are homogeneous. So so this is the PP curve, and what does it say? It's telling us what the price that each firm is going to charge. And so it's going to be a function of whatever its marginal cost is. And so that's going to be this term C here. But notice that we're not in perfect competition. So the price that my firm is charging is not equal to its marginal cost. We add on this additional term here, which is going to reflect the number of firms that are in the market, and the elasticity of, the sensitivity of consumers to price. And so notice that as n goes up, as n goes to infinity, this term goes to 0. And so what does that mean? That means as n gets really large, as n goes to infinity, then the price that each firm is charging is going to approach C. And so as the number of firms in this monopolistic competition model becomes infinite or really large, we start to approach the perfect competition model. But of course, if n is small, n is finite, then we could have the prices are going to be much higher than, in some cases, above marginal cost. And I'll come back to that idea. Okay, so so one concept that's going to be important here is going to be the markup of the firm. So the markup of the firm is just going to be given by, some people like to call this mu, and so the markup is just going to be defined by the price that the firm is going to charge minus the marginal cost. And so the markup here is going to be defined by 1 over NB. As I said, as the number of the firms in the industry increases, price gets closer and closer to marginal cost. And so that means we get closer to perfect competition. And so if the markup is 0, if this mu here is 0, then this means that we're at perfect competition. However, the markup of the firm is also going to decrease as this parameter b increases. So if b increases, then p minus c gets smaller. And the reason is that if firms, if now I'm a firm that sells almonds and I set too high of a price, no one or fewer and fewer people are actually going to demand my product if I set a really high price for almonds. And so this means that the consumers are getting more sensitive to price. And so I can no longer charge as high of a price without greatly restricting the quantity that I can produce. And so the less sensitive that the consumers are to price, the more that I can charge a price that's higher than my markup. So next, let's come back to the CC curve, which I prefer to call the AC curve because it's just the average cost curve. But we'll refer to them interchangeably. So recall that the average cost curve, what did we say that this was earlier? Well, the average cost curve for some firm I was given by CI plus FI over QI. But we can make a couple assumptions now that firms are going to be homogeneous. And so we can note that now that we have homogeneous firms, each firm's marginal cost is going to be the same. So CI is now equal to C. FI is now just equal to F. And QI is now just equal to Q. So that's the first simplification we can make of this average cost curve. The next we can realize is that each firm is going to produce the same output. And we've already justified that each firm is going to produce S over N. And so I can just, instead of having this Q here, I can just plug in for Q equaling S over N. And so what is that going to give me? It's going to give me C plus NF over S. So this is going to give me now not the average cost of a good in response to what my individual firm sells as a quantity, but the average cost for every firm, every identical firm that's going to be in the industry. And so what is this saying? Well, one, I just want to come back and say, what's the CC curve? This is frequently defined to be the CC curve when we have homogeneous firms. And it's saying that the average cost of a firm in my industry increases in the marginal cost of production. That makes sense. Plus, it's also going to increase as the number of firms is going to increase. And I'll come back to why that is. But it's the average cost is going to increase because whenever the fixed cost increase, that makes sense because if I'm selling the exact same number of units, but my fixed cost increases, then you can see that I have less number of units to spread out the fixed costs, and so it makes sense that the average cost would increase with the fixed cost. But it's also going to decrease as the average size of the market increases, and so this is what we're going to call economies of scale, and I'll come back to this effect later. But I'm just trying to give you a sense of how average cost moves with each of these variables. Okay, so coming back to why average cost increases when n increases, we can note that as n increases, as the number of firms increases, if we're holding the market size fixed, then noting that Q is equal to S over N, if we increase N, then Q is going to decrease if we hold S fixed. And so we can note that as N increases, the output that each individual firm is going to produce is going to decrease. And that's going to increase average costs because now, again, there's less quantity that a firm is producing with which to spread out its fixed cost. Okay. Likewise, you can see that S has the opposite effect. So if we increase S, that's going to decrease average costs, and the reason is going to be reversed. It's going to be that if S increases, then now each firm is producing a higher quantity, and so each firm has a higher quantity that it's going to be able to produce, and it can spread out the fixed cost more among the higher quantity of goods it's producing. And so it makes sense that as S increases, the average cost would decrease. Okay, so now we know what price each firm is going to charge and the average cost of each firm. And it's fine to examine one firm because if all firms are identical, then just by examining one firm's actions, we examine the actions of all firms in the industry. So we've already attained a solution for what price each firm is going to sell to maximize profits. But what we don't know is going back to this PI, we don't know what the average price is going to be that the firm is going to charge. So we know that the price that each firm is going to charge is a function of these parameters, but you can note that the one thing that we don't know here, we were already told at the beginning what C is. So C we know, and B we know. Those were told to us from the beginning. But the one thing we don't know is we don't know what the number of firms is going to be. And so if we're trying to figure out what this value that each firm is going to charge, we know what the rule is. So we figure that out. But we don't know the actual value of what the price is going to be. Sorry, I think I said that a little bit unclear from the beginning. But we want to figure out what the average price is going to be. We know what the rule is for what the price is. But in order to figure out what P is, or P bar is, we then need to figure out what N is going to be. So we need to bring in another assumption to figure out what N is going to be here. So we need to have a second condition. And so the second condition is going to be the firms here are going to earn zero profits. So if the first part, if doing what I did was the monopolistic part, the monopolistic part being that, again, when we were going through what the optimal price and quantity my firm was going to charge, we used that marginal revenue is equal to marginal cost. If this is the monopolistic part of the monopolistic competition model, then the competition part of the monopolistic competition model is going to be the firms earn zero profits. And so you can see here that why it's called monopolistic competition is that it has a flavor of the monopoly model and it has a flavor of the perfect competition model. So in perfect competition, we know that all firms don't earn any profits, but in perfect competition, price is equal to marginal cost rather, and so that's the main difference that we have here. So I went back just to sort of emphasize that point, but in order to solve for n, let's use this zero profit condition. So again, I said that a firm's profits are just going to be given by revenue minus cost, where revenue, recall that we said that revenue is just going to be equal to P times Q minus whatever its cost function is. And so what does it mean for a firm to earn zero profits? So if we say that a firm earns zero profits, then I'm defining this PI here. This is going to be my firm's profits. Sorry, I think I didn't. I'm not sure if I defined that earlier. So this pi here is representing a firm's profits. So if a firm's profits are equal to zero, then equivalently, the condition that this is saying is that noticing that profits are equal to PQ times Q minus CQ, then it's the same as saying that Q times Q has to be equal to C of Q. And so if I just divide both sides by Q, then these Q's drop out. And so what I'll be left with is this expression that P has to be equal to CQ over Q. And so I can recognize that the right-hand side of this is just going to be the average cost, and the left-hand side is going to be the price that each firm is going to charge. So I can recall that what I called this was the left-hand side is the PP curve, and the right-hand side is what we're calling the CC curve. And so the equilibrium number of firms, and also therefore the price, is going to be given by the intersection of the PP curve and the AC curve. And so what did we let's just go back and plug in for what we determined to be the PP curve and the AC curve when we have identical firms. So recall that we said PI was going to be equal to C plus 1 over NB, and AC, our average cost, was going to be given by C plus NF over S. And again, all of this is under the assumption that each firm is identical or homogeneous here. If we set these equal to each other, we can notice that if we just subtract C on both sides, those cancel out. So we'll come back to this later, but it's important to note that none of the determination of N star depends on these marginal costs because they just cancel up and cancel out. And so now what we have is we have that 1 over NB is equal to NF over S. And so again, what we need to solve for here is the equilibrium number of firms that we have. And so what we need to do is we need to solve for n by itself. So what's the way to do this? What I'm going to do is I'm just going to multiply both sides by n. These cancel out. And then I'm just going to multiply on both sides by S over F, excuse me. So what I'll be left with is n squared is equal to S over BF. Okay, and then if I just take the square root of both sides, then what I'll get is the square root of n squared is equal to plus or minus the square root of BF. Obviously, the square root of n squared is just equal to n. And then again, the right-hand side is plus or minus S over BF. Now, formally, mathematically, when you take the square root of both sides, this is equal to plus or minus S over BF. But notice that economically, we can rule out the negative case because the number of firms can never be negative. And so this is just a positive square root of S over BF because note that, again, economically, it doesn't make any sense to have negative firms. The number of firms can never be any lower than 0. So we get this rule that the equilibrium number of firms is then just equal to n star, equal to the square root of S over BF. So now that we have the equilibrium number of firms, we can just figure out what the equilibrium price is going to be by plugging in for n star here. And so note that if n is equal, if the equilibrium price is equal to C plus 1 over NB, then just plugging in for n star here, we get C times 1 over B, and then BF over S. And so then the simplifying thing that we can do here is we can just notice that the square root of B times 1 over B is equivalent to writing negative B times -1 times B to the 1/2. And so what are we left with? We're left with B to the -1/2. And so that means that, which is equivalent to just writing 1 over square root of B. And so we can simplify this term here by just writing instead C plus F over SB. Okay, and so that's what we get right here. So hooray, we've used both of our conditions to now figure out everything that you'd want to know about this model. The price that firms are charging, the number of equilibrium firms. Again, recall that we can just, if we wanted to figure out the quantity that each firm was going to produce, we could either plug back P star into our demand function, or we could just recall that we've made this simplifying assumption that all firms are homogeneous, and so we know that in equilibrium, each firm is just going to produce S over N, and then we also know the number of firms. And so that's everything we'd want to know for this model. And so this is the equilibrium. We can note that going back, we saw that the CC curve is just defined to be AC equals C, oops, excuse me. C is equal to NF over S. So we can note that the CC curve, or the AC curve, is increasing if we just plot this equilibrium in terms of the price on the y-axis and the number of firms on the x-axis. Then we can see that the average cost is increasing in the number of firms. Again, why is that? That's because as the number of firms increases, each makes a smaller quantity. And so they can spread out that fixed cost among fewer units of output. And so CC is increasing with the number of curves. Number of firms, excuse me. And then the PP curve is just given by C plus N over B. And so recall that the price is going to be decreasing as the number of firms increases. As the number of firms goes to infinity, the PP curve gets close to just the average, the marginal cost C. And so the PP curve is going to be decreasing. And then the intersection of both the CC curve and the PP curve are going to tell us the equilibrium number of firms and the equilibrium price. So those are going to be the main takeaways from the model. So hopefully that will be useful. And next, I'm going to go through a couple of numerical exercises which help build your intuition for this model.